Alright, let's continue our discussion on logarithms and their rules. We have, in a previous discussion, we covered the first three rules, the product rule, the quotient rule, and the power rule. Now, let's continue on with two more, I guess you'd call them rules. When you have a log A raised to the same number, A, it's equal to 1. Now, for example, let's say log 3, this is equal to 1. Now, how do we know? Well, let's apply the, let's convert this back to an exponent format. If you remember doing that in a previous discussion. This here is your base, 3. This here is what it's equal to. And your exponent is that right there. Well, here makes logical sense. 3 raised to the 1 power is equal to 3. So that's where the identity rule comes from. Okay. Another one that is similar to that is the 0 rule. Log A 1 is equal to 0. So any log with a base and a 1 is always equal to 0. Now let's go back and apply and convert this to exponential form to see see how we get that. Let's say let's not do that. Let's say log 4 1 is equal to 0. Let's convert that to an exponential format. Again, the 4 is our base. It's equal to 1, and the 0 is our exponent. Well, we know from the 0 property of exponents, or the 0 rule of exponents, that any base raised to the 0 power is equal to 1. So, anyway, so that applies here. That's another rule that you need to remember as you're working through logarithm problems. Something else we need to cover in this discussion is dealing with square roots and logarithms. When you've got something like this, log 7 to the square root to the cubed root of x to the 6th. Well, first of all, we need to remember how to rewrite a radical like this one. If you were to rewrite this, you would say x, and you'd make it a fraction as an exponent. 3 would be your base, and the top would be your 6. Now you can convert that. 6 over 3 will simplify to make just x squared. Okay, with this in mind then, let's go back to our original problem. Log 7 and change it to x squared. So really, this right here can be written as 2 parentheses log 7 x. Okay. We've got one more thing we need to discuss, and that is additional tips when working with logarithms. Now, you have log 2 parentheses x minus 7 is equal to log 2 parentheses 2x minus 10. Now, from the onset, it looks pretty confusing, but remember that when you've got a log to the same base on both sides of the equal sign, those logs will cancel out. You can cancel those logs out and merely solve for these parts. X minus 7 is equal to 2x minus 10. Now, the requirement, though, is the log must have the same base, log 2, log 2. If they are not the same base, then you cannot cancel them out. So let's go ahead and solve this out here. First, always combine your variables. Negative x on both sides, giving me negative 7 is equal to x minus 10. Add 10 to both sides, giving you x then is equal to 2. Boy, I cannot count today. It's not 2. It is 3. 7 minus 10 from 7 gives you 3. There's one more thing I need to mention concerning this rule, or tip, if you will. Let me erase this so I have a little room to work with. Let me write this down. What if you had a problem like this? Log 4x minus log 4 3 is equal to log 4 parentheses x minus 6. Now, you might think, well, they all have the same basis, so can we just cancel out the logs? No, you cannot. You've got two logs over here. We need to reconcile this first. Do something with this section right here. Now, if you remember from part 1 of the previous discussion, this here can be written or rewritten as log 4 x over 3 is equal to log 4 x minus 6. Now we have one log here, one log there. Now let's cancel out. Now that we've done that, and we end up with x over 3 is equal to x minus 6. Okay, now we can solve for x. Let's divide by 3 first, or I'm sorry, multiply by 3 on both sides. So we multiply this by 3, and we multiply this by 3. These 3's would cancel out. And what would happen then is I end up with x then is equal to 3x minus, what, 18? Okay, 18. Kind of sad looking 18. Anyway, let's finish this up. Subtract 3x on both sides. We get then 2x, negative 2x, is equal to negative 18. Divide by negative 2, and therefore our x then is equal to 9. Okay, so those are some important tips to remember when dealing with logarithms. If you've got the same log on both sides, cancel them out, but remember, you must have just one log on each side before you start canceling. If you have a situation like this, use the other properties or the other rules that we've talked about to try to reconcile those to where you can get one log on one side. Alright, that concludes our discussion on the logarithm rules.